Hello students, welcome to Python programming class lecture 15. We are learning unit 2 part 1 a case study. So let's check the syllabus once again. The turtle module, simple repetition, encapsulation, generalization, interface design, refactoring, and finally docstring. So in previous lecture, two topics are completed. Now coming to the two topics, encapsulation and generalization. In next lecture, we will learn another three topics. Let's get into the today's lecture, encapsulation and generalization. What is meant by encapsulation? Encapsulation means we are wrapping up the data. So we are wrapping up the data complete code into one piece of code. That is called encapsulation. We are what is the advantage here means we are reusing the code. Right? Let's check this example. We are defining a function square. So to draw a square of t, this is a parameter, right? For I in range, so how many times? 4 times. Fd, what is the parameter? T comma 100, left turn comma t. Instead of giving Bob here, I am giving t parameter. So square of Bob. So this is function calling. So when we call this function, t is a Bob. So same thing is executed for Bob object, right? Similarly, you can give anything. In place of Bob, give Ram, right? Same function is executed once again. So this is called encapsulation. Repeatedly you are using the same program. That is encapsulation. Now coming to the generalization, same concept. Here two parameters are added. So t comma and you are adding length also. So in previous program there is no length. You are drawing 100 steps. So you are moving 100 steps left turn, 100 steps left turn, 100 steps left turn. So that is predefined. You are giving only 100 steps. There is no dynamic way. So here you are adding a parameter. So that is called generalization. So in the previous version, it is same size. But in this version, it is any size of the square. So here the square is t comma length for I in the range 4. So t comma length, fd forward, t comma length which are given here, then left turn. Suppose give 100 forward, left 100 forward, left 100 forward, left 100 forward. So each one is 100. Suppose give 50. If you give 50, so 50 forward, 50 forward, 50 forward, 50 forward. So like that generalization works. So that is generalization. So that's the concept of encapsulation and generalization. That's the today's lecture. We will meet in the next lecture. Thank you.